forget because I will forget it if I don't turn it on now. All right. Well, it is 9 o'clock. Even though there are only like five of you in the classroom, I don't care. I'm gonna start the class. So what we'll do today is we're gonna look over the exam from last semester, from spring 2025. I think a really good strategy for you is to take notes, okay, even though it is being recorded. The reason is I'm not going to write anything on the exam itself. I will verbally describe how to solve the problem, okay? So if you have an exam you printed in front of you, that's great. If not, it is still okay because everything has a line number. Okay, so all you need to do is to write down on which line what is the problem and how we're fixing it, and also on which line, which register has what value, how it relates to the C code. So everything can still be written down. Okay, and I will also describe strategies at times. And you can, with those, you may not be able to copy the strategy, quickly enough. You just look at the clock, okay? You just go like, okay, tag talk about strategy at about this time, and then you can revisit the video, and then you can take all the time that you need to write down, whatever strategy you think is going to work for you. So this is just a little prefix, okay, just so that you guys are more prepared, to receive the content of today's lecture. Do we have any questions before we proceed? Okay, I don't see any questions, so we're gonna go, we're gonna start. All right, so this is an individual exam, and I am very tempted to keep the same, no bathroom break thing, with the other exams. So I will still be considering that, but that's very likely that I will continue with that policy. Um, your exam is going to be next Thursday. Okay, that will be on the 18th. So let me double check. Okay, so the first thing is we need to double check when your exam is scheduled. But I believe that it is scheduled next Thursday. The most important part is the time. Okay, so you need to look at the time when it is scheduled, because I believe it is 8 a.m. It is not 9 a.m. So let me double check first. Okay, let's go ahead and double check. This is the actual calendar. I think I might have put it on the calendar already, but I will double check. I think I did, but it's on the 16th. Oh, okay, not the 18th. So I correct myself. It is on the 16th at 8 a.m. So that means you need to make sure that you set your alarm clock accordingly, because most of you are used to coming here by 9 a.m. So you need to remember to set your alarm clock. Make sure you have all the transportation stuff, kind of arranged ahead of time, possibly with a backup plan, okay, just in case your usual mode of transportation somehow does not work. You need to have a backup plan. I think one day of Uber is not too much, okay? So just kind of have a backup plan. But the most important part is know that the exam starts at 8 a.m. It ends at 10 a.m. It's a 2-hour exam. Okay, so you got to plan for that. Make sure that you're not stuffed with breakfast. So a stop at IHOP may not be the best idea. Okay, so you want to eat something before, but you don't want to eat too much. Okay. Okay, so it is already scheduled. It is good. So now we're going to go back and look at the exam from last semester. I hope you all have a chance to look at it. Okay, if you don't, it's still okay because I will go over everything. So there are a few things that I need to kind of disclose here. Okay, so I will probably roll up the projection screen, and just kind of show you what you can do in the exam, how you can mark up, and indicate your corrections. So I will kind of do that, at some point. Your format will be about the same, if not identical. Identical. So that means the very last page, if you go all the way to the last page, it is the actual C code. Okay, keep going, keep going. There we go. So the very last page is usually a one page of C code. So what you can do is, it will be paper clipped, okay, just like the other exams. So what you want to do probably is to take the paper clip out, reattach it to only the last page, okay, so you don't lose the paper clip. Put that C code on one side, and then work on the assembly code on the other side. So this way you have a view of the actual C code to give you the context, but at the same time you can work on the assembly code on the other side. You can mark up things as much as you want to, okay? But for the answers, for the actual answers, you have to make it clear. This is a correction, okay? And this is why it needs correction. So I will explain that in just a little bit. So are we still doing okay so far with how the exam is going to go? Okay. Once again, just a reminder, you can bring in anything and with whatever amount you want, as long as they're on paper, like physical paper. No electronics during the test except for a calculator. I don't think a calculator is going to be super duper helpful, but for those of you who want to bring a calculator just in case, that is okay. Okay, but no other electronic devices. Headphones, need to be off. Okay, um, that the usual stuff. All right. So, do we have any questions about the C code of the exam from last semester? So I was just kind of quickly, or not quickly, just kind of gradually scroll down and see if you guys have any questions. So we have a structure called node. We have a frame, another structure called frame. One has payload as a void pointer, and it also has a member that is a pointer to a not to a struct node. Can be itself, okay? It doesn't mean that it cannot be itself. It's just a pointer. And then we have P node as the first member of frame, and then previous frame, also is a pointer to a struct frame. So there are two structures in this particular program. We have a global variable called circle. It is an array, because we see the square brackets here, of struct nodes. And this is how the global variable is initialized, okay? Um, so do we have any questions from line 13 to line 17 in terms of the C notation? We do not. Okay. Now this is really standardized, your C code. So if you do have any questions later on, okay, and you go like, okay, wait, I do have a question, but the class is already over, you can ask Gemini or ChatGPT. Okay, these are really standardized your C notation. I did not use any trick that is off the book, so to speak. And then we have the function that for the most part is what I mean, there are two functions. There's main and there's isLoop. So isLoop looks kind of messy, okay? And it is messy, but do we have any questions about any particular line oh, I don't understand the syntax of this particular line. So do we have any syntax issue regarding C++? It's actually plain C. This is not even C++. So do we have any questions? Okay, I don't see any hands. Okay. And then we have main. Okay, if we scroll down a little bit, main is really simple. Okay, it's a very tiny little main program. So, assuming there are no questions about the C code, you can ask those questions later on because our job is to check the entire program. So that means we're going to go over these lines one by one, okay, as we go over the assembly code. So if you have your laptop computer or the desktop computer here, you can open the same document and stay on one page as I go through the other pages. But if you don't, that's fine too. Um, all right, so instead of describing, okay, in words what you're supposed to do, I am going to give you some examples. There we go. So the program starts here. We have a no op instruction, okay? It is not wrong, okay? It is just, if you're not running in TTP, not if you're not running this in Riffle Spider, the no op is really not necessary, but it's not wrong. We have LDI D0, decrement D, LDI B dot 6 plus, store to D, where D points to, the content of register B, and then JMPI to main, and then the halt instruction. I see a problem already. Okay, do you guys see a problem? What problem do you see? We are just pushing the return address and then continue execution in main, and then the usual halt instruction after main returns. So where is the problem? So there are two ways to detect this problem. Okay, one is simply pattern recognition without knowing anything about programming. Okay, so if you only practice pattern recognition, you go like, hey, tech, we usually do the decrement D after the LDI whatever register dot six plus. Okay, so that's only doing it by pattern recognition, which is a way, not preferred, to detect a problem. Okay, so one thing you can do is to exchange those two instructions. Okay, but you have to tell me why. Okay, so that's why an approach that is strictly based on pattern recognition will only get you partial credit. It won't get you full credit because you need to tell me why it is a problem. Okay, so why is it a problem when we switch the order between line 61 and line 62? Mm, that's not the issue. You can always, reserve because as long as the ordering between the decrement D and the store instruction are not reversed, it's still okay. You're still reserving before you store. The only thing that would be a problem is you store before you reserve. Okay, so the between line 61 and 63, as long as decrement D is before line 63, you're fine. Okay. Yep. 5. It'll be 5. Yep. Go ahead. Okay. So the problem is the code as it is. What is the problem? If I run this code as it is, what is the problem? What would be the symptom? But what is main going to return to? Yeah, go ahead. Yes. Well, not so much. Okay, so you're correct. It will return to whatever byte is after the halt instruction. I think that's what you meant to say. Yes, that is correct. Okay, it will give us the wrong return address. So to fix the wrong return address, you can either change this 6 to a 5, or you can swap your line 61 and 62, but you have to be able to tell me what's wrong with this code. As it is, what is wrong with it? Okay? Because I don't want you guys to just go by pattern recognition. And you go like, why is it not okay? Why is tech so strict about not answering the questions only by pattern recognition? What do you think is the answer to that question? That won't get you very far in a career. Okay? Period. Okay? There's no The AI can do pattern recognition much better than you or I or anyone alive can do. So if you want to make a living out of just being able to recognize patterns, yeah, it's not going to work out. Okay? So that is why, okay, I need you guys to really understand how things work and why it is not working as it is. Okay. So I'm going to show you, how to answer this particular question by, writing on the whiteboard. So this part you might need to, find your own way to kind of take notes because this part definitely is not going to be recorded because I'm doing something on the whiteboard. So you would say, okay, there are two ways to fix it. You can say cross this out and say this needs to be a 5. That will get you partial credit. Okay, even though you fixed the problem, it will get you partial credit because you did not explain to me what the problem is. Okay, so now you have to say, okay, as is the main returns to the location after the halt opcode. That is the reason. And then the fix is to change it to a 5. Okay, the reason why you change it to a 5 is you count the number of bytes from the LDI instruction to the halt instruction. It turns out to be 5 locations, 5 bytes. Yes, you still have to explain it. Yep. So the alternative is not to cross out the 5, cross out the 6, and turn it to a 5. And you can also just do this, but then you still have to explain it. Hmm? It's between line 60 and line 61. I'm not sure what you're saying. Oh, you're right. Okay, you're correct. Swap the wrong lines. Yep, it is correct. Swap these two. Very good. So the key is the explanation. Okay, if you do not explain, you're guaranteed not to get full credit. Are we good so far? Yep. Hmm? Yes, it will still be the same because you are saying as is, okay, without correction, what it's going to do. So how you fix it, either by exchanging the position of line 61 and 62, or you change the 6 to a 5, it will still accomplish the same thing. They both will fix the problem. Yep. Okay. So that's what I mean by you can that's how you indicate the change, and also how you indicate the problem. Okay. So I'm gonna lower the projection screen again. Okay, so let me go do that. All right. So now we move on. Okay, so now we get to struct node. This is the C code. This is the assembly code trying to define the same thing. Payload is the first member of the struct node. Okay, so that's good. It has an offset of 0 from the beginning of the structure. P next is the next member. It is the offset to the previous member, which is payload, plus the size of the previous member. And because payload is a void pointer, it is a pointer. Every pointer only takes 1 byte. So that's why we have this 1 over here. And then size is always going to be a label to define the size of a particular structure. It would be the offset to the last member of the entire structure plus the size of the last member of the structure. So in this case, because p next is a pointer, that's why it is only using 1 single byte. So I don't see a problem from line 72 to line 74. Everything seems to be fine. And then we have another structure here, which is frame. So same kind of deal. P node is the first member. It is at the beginning of the entire structure. Therefore, the offset from the beginning of the structure is 0. Previous frame is the next member. So it is the previous member, which is P node, plus the size of P node. Because P node is a pointer, that's why we only add 1 byte. And then we have the size of the entire structure, which is the offset to the last member of the structure. Okay, so this is the offset to the last member. And then we add 1 because previous frame is also a pointer, and pointers are all 1 byte wide. And that's why we add a 1 here. So do we have any questions about lines 81 to 83? They are correct. There are no problems. So are we good? Okay, all right. So we're going to move on. So now we are moving on to the definition of the global variable circle, which is an array of struct nodes. So this is the C code, and now we compare that to the assembly code. This 0 becomes this 0 here. This is the address of member 1 or element 1 of the array circle. Okay, so now the question is that correct? And how come that? Okay, so look at all 3 expressions. They all look a little bit different. This one versus this one versus this one. They all look a little bit different in terms of the placement of the operands and sometimes the operators, but they are actually the same construct. Okay, they are all correct. So for the people who are thinking, I'm not really sure how to read reversed Polish notation, that's okay. You still have 1 week. Okay, you can rely on online resources to help you understand how to read reversed Polish notation. Okay, this is something that we have talked about, in the middle of the semester, and so you can print out the entire instruction of how to read the RPN or reverse Polish notation and bring it with you. Follow the instructions, on RPN. Okay, you can ask Gemini to give you a one-page summary of how to read and process RPN, and bring that with you. Print it out, bring it with you. So you have resources that many other students in previous semesters do not have access to. Okay, so the way we process this, so I'm not deferring everything to AI. I will try my best to explain. So the way this works is you have one, you push the one on the operand or value stack. You have node size, you push it on the stack as well. When you have the multiplication, what it will do is it will pop two items from that stack, perform the multiplication, and then push the product back on the stack. Okay, so now you have one single item left on the stack, which is one times node size. Yes, that is just node size, but it would be the only item on the stack. After that, you see circle, which is really just a label, so it's a value. You push that on the stack too. So now once again, the stack has two items, right? And then you see the operator plus, which will then pop the two items from the stack, perform the addition, and then push the sum back on the stack. And that is the final result because that's the entire expression. So that's how RPN works. Okay, it is also based on stacks. And since we have talked about stack being a last in, first out construct, I would assume that you understand how to perform these operations now that we have described how to read RPN as stack related operations. You see a value, you push it. You see an operator, you push, you pop the number of values from the stack, perform the operation, push the result back on the stack. That's it. It is actually much easier compared to parentheses. All right. So all three are actually correct, okay? Because your circle is the beginning of the entire array, and then this is the offset in number of bytes from the beginning of the entire array to find element one. So that is actually correct. This one is also correct. Okay, this time, this is the product. So this is computing the number of bytes from the beginning of the entire array to element two of the entire array. And then we add the actual address of the entire array back. And now you have the address of element two of the entire array. So this one is also the same. Okay, the only difference between this one is the ordering between node size and the multiplier. But since multiplication is commutative, yes, I just quoted a algebra term. Um, they are equivalent. Structurally, they are equivalent. Are we good so far? Okay, so all of these are the same. Okay, they all work in this exam. All right, so now we are moving on to some of the thicker stuff, which is loop. So this is where things get a little bit thicker, okay? So you might need to pay attention. And if there are any parts that you cannot understand like right away, you can always jot down the time, and then you can go back to that particular segment of the lecture on YouTube. All right, so we start with a bunch of label definitions. F is our first local variable in the C code, and this is why having the C code on the side can be helpful because you're reading just the pure C code without interleaving with assembly code. But you can see that I'm trying to be kind here. I comment out all the C code and then you put all the related assembly code next to the C code. So try to make use of that as well. All right, so this is our first local variable f, okay? It is at the base of the entire call frame. Okay, so now you have to remember what is a call frame, what does it do, what does it contain, and so on. And where do we find that? Yep, and it actually has examples, with like pictures of a stack and offsets and stuff like that. So if you have not read or have not, really tried to read, into the actual meaning of that particular reading material, it would be a good way to prepare for the exam is to read it and maybe print it out, bring it with you, okay? But that is not going to help unless you already understand the content. Okay, so that's the deal. Okay, you're bringing a lot of pieces of paper won't help you unless you already understand what is on the paper, and you just need to help you to assist you with remembering things that you already understand. All right, so next item is FPTR. Okay, so FPTR is at an offset of frame size away from F. That is actually correct because F is not a pointer. It is an actual struct frame. So that's why you when you add you have to add the size of the previous local variable to the offset of that variable to get to the offset of the next one. So this line is actually correct. There's no problem here. Now we move on to result. Result is the third and last local variable. The offset from the base of the frame to result is the offset of the previous local variable plus the size of the previous variable. This one is wrong, okay? This is wrong, this is incorrect because FPTR is a pointer to a struct frame and it's not even node, okay? So this is like wrong in multiple ways. So what you need to do is to fix this by crossing this out and replace it with a 1 and tell me why it needs to be a 1. Okay, the reason why this has to be a 1 is FPTR is a pointer. It is not a struct node at all. All right. So then we move on, okay, because this result is the very last local variable. So LVS is always, okay, I try to be very consistent with this. So LVS is always the offset to the last local variable plus the size of the last local variable. This one is correct because result is just an unsigned 8-bit integer, otherwise known as a byte. And then we have P node, which is our first parameter. It is LVS1 plus. This one has to do with the return address. Okay, so the return address is sitting between the local variables, if any, and the parameters, if any. And then we have pref or previous frame. It is also just 1 byte away from P node because it is the second parameter, and P node itself is a pointer, so it only takes a 1 byte. So all of these definitions are correct, except for this guy over here. Okay. All right. So then we move on. Okay. So what we normally do is we allocate space for the local variables, and this is not the typical way that we do it, right? So anyone who cross out line 111 and 112 and replace it with the usual code that we do it will be marked incorrect because this is actually correct code. You do not correct code that is already correct. So I will take points off, okay, for people who make changes when they are not necessary. Hmm? Oh, plenty of people go negative in past semesters. Yes, I'm very kind. I round up to zeros. Yes, but to your question, yes, people have gotten negative scores because they ignore what I said in class and they decided to shotgun the whole thing, and the shotgun approach definitely does not work. The only way to approach this exam is with a scalpel. Okay, so that means to use a scalpel, you need to know where to put that incision. Okay, so how do you find out where to put that incision? You have to understand everything. Okay, everything has to be clear in your head. You have to understand everything. So just because your pattern recognition brain does not recognize line 111 and line 112, now you have to ask yourself, is it a problem? Or does it actually get a job done right? Okay, so now you have to say, what does line 111 put into register C? It's a RPN, you push a 0 on the stack, you push LVS on the stack, and then you perform a subtraction. It becomes 0 minus LVS, which is a negative number. You store it into register C. And then what do we do with register C? We add register C to the stack pointer. You're adding a negative value to a non-negative value. or I mean, it has the same effect as subtracting. Okay, so basically it works. Okay, there's no problem with lines 111 and 112. So that's why if you only do it by pattern recognition, you'll be tricked by something like this and do a unnecessary correction which will get points taken off. So let me also talk about how I take points off. For each correct answer with proper explanation, let's just say it is 1 point. Okay. Then for each incorrect correction, it will cost you a quarter of a point. So that means you have to make four incorrect corrections to make up for one correct point. I think that is fairly generous. Okay, so some people might still be tempted to shotgun, but I would still advise against shotgunning. Does everybody understand what I mean by shotgunning? Yeah, whenever you see there might be a problem, you try to fix it. You're hoping that it is one of the things that you actually need to fix. Yes. Okay. So this is RPN. Okay, on this side, you push a zero on the stack. You push the LVS on the stack, and then you see the operator, which is a subtraction. You pop those two from the stack, and then you perform the subtraction, which is the first thing that you push minus the second thing that you push. So essentially, this is the same thing as 0 minus LVS. So that means it is kind of important for you to know how to read RPN. Okay, as I said a little bit earlier, you have resources. You have been warned. You can bring any amount of paper with you. I have explained it already, and you can ask Gemini to give you a one-page explanation of how to perform RPN. You can ask Gemini to give you exercises, okay, to practice, how to use RPN. And you can even feed this into Gemini and say, this is RPN. What does it mean? How do we process that? You can do all of the above. You have 1 week to do this. I know you have other exams, but still, I mean, 1 week is a lot of time for the whole exam. Yes. And there are still people who ended up getting, like, initially a negative score. But that's a mentality. Okay. I don't think it's common. It's a mentality thing. Some people just decided, I'm going to shotgun this anyway. Okay. It's kind of like, I tell people, don't shoot yourself in the foot, but I want to. So what do? I just step back. It's like, okay, I think I'm at a safe distance. Go ahead. But I will tell people, I warn people first, but I cannot stop people from doing whatever they think is the right thing to do. Alrighty. So all of these labels are done correctly, except for this one here. This is also correct. So now we get into some itty-gritty stuff. Okay. So when you get to the itty-gritty stuff, my recommendation is to comment every single line and tell me, or tell yourself actually, what is in a register after the operation. Okay, that would be my approach. Okay, most people disagree. Okay, from from previous semesters, most people disagree and they just go like, no, I'm not going to do that. I can keep track of what is in the register in my head. Mm, yeah, but that doesn't work out so well for many people, but it does work out for some people. So line 115 is going to put a 0 into register A. Line 116 is going to put the offset of result from the base of the frame into register B. And then line 17 is going to add the stack pointer, which is pointing at the base of the frame, to the offset to local variable result. And as a result, register B ends up with the address of result. Yep, exactly. It is missing the instruction to store A to wherever B is pointing to. Okay, so that means now I can show you how to correct this and what I expect to get full points also. So let me slide the projection screen up and then I'll go ahead and write down, what I would expect the full answer to look like. All right. So, okay. Let's see if the first erase the one from before, like so. Okay. So the way you do it is you basically have to insert a line, and there are many notations you can do it with. This is one way to do it. So you can basically say ST, in this case BA, and then you just go like in order to store the value to the left hand side. Okay, because without this, you have computed this, but you haven't really finished the store. So I need you to tell me why we need a stored instruction here. But in addition, if you read the instructions for the exam, which I encourage you to do before your exam, okay, read the instructions of the exam from the previous semester. I need you to tell me anytime you have a problem, anytime you have to fix something like this, you have to tell me what is in register A and what is in register B. Okay, so that means you have to fully comment everything now. You have to say that A has a 0. In this case, B is the offset to result. So the way I do it is I just look at the address of result minus the stack pointer, because the stack point does point to the base of the frame at that point. Okay, so this is actually valid. And then on this line, register B becomes the address of result. Because without the previous comments, I cannot tell whether you just recognize things because it is the pattern, or whether you actually know why you need a store instruction and why you need to use those two specific registers. So that's why, I need all the comments in order to get full points. If people just give me an insertion of the store instruction, that will be at the most 2 points out of four, or one half of the points. Yep. You can say that B is the left hand side, A is the right hand side. That works too. Yep. So you can simplify this, okay, and just say that B is the left hand side, and then A is the right hand side of the C code. Right. It is implied of the C code because the assembly code does not have a right hand side versus a left hand side. Yep. But you need some kind of explanation of why we need a store instruction to show me that this is not just you recognizing a pattern. Yep. So are we good with this one? What I expect you guys to do in order to get the full points. Okay. All right. So let me lower the screen again. All right. So we have, then we move on to the next statement, which is this statement over here. So now we look at the right hand side. Okay, this is P node. Um, so we have the offset. We have the, oh, wait, something is missing here between line 119 and line 120. So some people can do it by pattern recognition and say, oh, we're missing an add instruction. We are missing an add AD over here. The question is, why do we need it? So let me go back to, let me erase the screen again. Ah, probably can leave the screen raised all the time now, but because of the glare, it doesn't, people who are sitting in the front particularly may see the glare, and it's not nice. Okay, so, okay. So over here, we are missing one instruction. So you basically go like, okay, this is where we need to insert, add AD. Okay, that will get you half the points. Okay, so you have to tell me why we need this instruction. So now now you need to comment the first one, which is A is the address of P node minus the stack pointer. And then on the second line, you now have to explain, add D to A so that A is the address of P node. So that would be acceptable for this particular bug that we are fixing. Okay, so I can see how some people are looking at this also as a pattern. This becomes the new pattern that they're learning to apply it. So because I know that those people are learning this as a pattern, I will also design the final exam to counter that particular pattern recognition. In other words, do not rely on pattern recognition. Okay, you have to understand the code. I'll be clear on that. Okay, because the objective of the class is to make sure that you understand the material. It is not to make sure that people pass the class. So people who do not understand the material are not ready for the next class or the class that you'll be taking after you transfer. Okay, so that is kind of why I need to design the final exam the way that I designed the final exam. All right, moving on. So we need one instruction before line 119 and line 120. And then after that, we have this whole thing here for the left-hand side. So this is the offset to local variable f, which is on the frame. And this is the offset to member p node of that particular structure. And we just add those two together. This is actually correct. Okay, there's no problem with this. And then we add the stack pointer to register B. So now register B becomes the address of P node as a member of the structure that is known as local variable f. So far so good, but I'm also missing a st instruction here to store the actual result. So this one we have talked about already. I'm not gonna go back and explain that. But in order to get all the full points, with the addition of the st instruction, now you have to tell me what line 121 and what line 22 did before the inserted line. Am I clear on that? Let me say that one more time. Line 22, 122 is okay, but we need a store instruction because otherwise, okay, this is a rule. Okay, I know by naming this, it becomes a pattern that some people want to use as for pattern recognition. If you have an assignment statement, you need to change whatever the left-hand side is. The only way to change the content of a memory location with TTP is a store instruction. Exactly. Okay, but what you're storing to what? That is the question. Okay, why are you storing A to B? What is in B that completes this entire operation? How did we set up register B so that B is the correct register to store to? That is the question. And you have to explain that. Are we good on that? Okay. So this time I did not write down on the whiteboard. I did talk about it, but I did not write it down. So you have to tell me after line 121 what is in register B, and after line 22 what is in register B. Okay, so you need to put those comments in because otherwise I will be asking you, but why are we storing to where register B is pointing to? What is the whole point? Okay, because so you have to explain that. Are we good so far? All right. So now we move on to the third statement in C, which is this one. So we look at previous frame, okay, we have the offset, we have the address, and then we do some really funky stuff over here, okay? So, register C has the difference between previous frame and P node as members of a struct P node. And that is, there's something really wrong here, okay? I'll explain what is, no, no, never mind, not really wrong here. And then we add those two, okay? We add that to register B. We add register C to register B, and it is also missing a ST instruction over here. Okay, so we got a few problems, okay? The first thing is we're missing an LD instruction between line 125 and line 126. Why? Without the LD instruction between lines 125 and line 26, even if the rest of the code is correct, what would I be storing to previous frame as a member of F? The address. Yes, I'll be storing the address. Is the C code saying ampersand pref frame, on the right hand side? Do we see an ampersand right here? Nope. So without the ampersand, what I'll be looking at? The value of, okay? That's why you need an LD. Is that okay? So that means you need to be able to map all the programs that we have done up to this point from the assembly code to the C code. What does it mean for each line of the assembly code? How does it relate to the C code? And you have to understand every line on the assembly side, because that is what this test, what the final exam is going to test you on. All right, so moving on to line 126. So what is line 126 storing into register C? It is storing the difference. It's basically pref frame minus p node. That's what it's storing. So you go like, okay, why are we subtracting the two labels? What does it mean? Well, the first question really is, what does each label mean to begin with? Okay, because you cannot answer the question of what is the meaning of the difference unless you can answer the question of what each thing in the subtraction, what does it mean? So, okay, how about you guys tell me what is frame underscore pref frame? What is the meaning? What kind of value is this label representing? Unfortunately, this question cannot be answered using ChatGPT nor Gemini unless you feed it the entire program. Then it might be able to figure that out. It is the offset from the beginning of a struct frame to the member called pref frame inside inside the struct frame. That's what it's representing. Okay. So what about the other one? It is the offset of a p node from the beginning of a struct frame, to the p node member. So what we are looking at here is I'm looking at two offsets of two different members of a struct frame, and I perform a subtraction. I'm looking at the number of bytes between two members of a particular structure. That's what I'm storing into register C. So why am I adding register C to register B? What is in register B at this point? So we focus on line 127, but the question is, what is in register B at this point? What was the last time we changed or updated register B? It is the address of member P node of the structure that we know as local variable f. Yes, that is correct. Okay, so what happens when you add to the address of member P node of the structure F the difference between pref frame as a member and P node as a member? You end up with, we're not adding the size of frame, we're only adding, so register B on line 127 is the same register B as a result of 122. And we already talked about on line 122, register B is the address of member P node of the structure F. So what happens when you add the difference between member pref frame and member P node to the address of member P node of F? Yes, you get the address. That is correct. You get the address of member pref frame of the same structure. Okay, so that is what you need to figure out, by looking at the code. Okay, so that means on line 127, register B ends up with the address of pref frame of the structure that is the local variable f. Once again, we're missing a store instruction here, so you need to insert the store instruction. But because you're inserting the store instruction, which stores register A to whatever register B is pointing to, you also have to give me an idea of what is in register B. So that means you have to go back and comment line 127, which means you have to go back and comment line 26, because line 27 depends on register C. Register C got its value from line 126. So that's the kind of thing that you need to do. Okay. And this is why my recommendation is to comment every line to begin with, so that you know what is in each register as you move forward. Is that okay? Do we have any questions about this? Okay, so after all the correction, this actually works. Okay, when I make the exam, I start with a program that actually works consistently with the C code, and then I go back in and mess around with it based on inspirations from your submissions. I look at the most common problem and also some of the not so common problems, and I just kind of sprinkle those problems into this code. Are we doing okay so far? So if this is a little bit tricky, you look at the time. Okay, it is 9:51. Okay, maybe 9:50. So you might need to go back to this point and go like, okay, I need to really digest this and slowly go over that discussion. Okay, just do it step by step. That will only help if you already understand the concept. Okay, this one does have a little twist to it, but it is still based on the concept that we have already talked about in this class, what each label is representing, what is a structure, what is pointed to a structure, and so on and so forth. So those would be the foundation. Okay, you need that foundation first before you can understand the more tricky code. All right, so moving on to line 128. Okay, this is the beginning of a conditional statement. So when I do stuff like this, I would look for, where's the else, if there's any. I look at the structure of the code, okay? Which means I would find it really helpful to bring one of those little post-it thing that is kind of long. So I would stick it to line 128, and then I'm going to ask, okay, where is the end of the loop, or the end of the conditional statement? So I will look for this label definition. I will scroll all the way down, okay, and go like, do I find that? Yes, okay. So I will check it off. So that means a checklist approach may work for some people. Okay, which means whenever you see a conditional statement, you ask, is there a label marking the end of the conditional statement? And do we have a way to get to the end of the conditional statement? So you check the control structure structurally. Okay, I know it sounds really redundant, but it is not. Okay, because I would do it kind of in a structural way. So now I look at this and go like, okay, so we need to escape the conditional statement or go to the else statement if there's one, and in this case there's no else statement. So we need to escape it if p node is null or if it is 0. So I would now check the code and say, are we checking it whether it's 0 or not? So we will look at the offset, we'll look at the address, and we are going to check the address of p node and see whether it is null or not. Does that sound like what line 128 is doing? Is there an ampersand in front of p node? No. So we are not looking at the address of p node. We're looking at the value of p node. So if you have the address of p node, how do you get to the actual value of p node? An LD instruction. So you need an LD instruction between line 130 and line 131. But you have to explain. If you don't have that LD instruction, you'll be comparing the address of p node to null, which is not what the C code is asking for. And then you have to go back and fully annotate line 129, 130, because that's how you put a value into register A. Because without explaining to me what is in register A, there's no way I can accept the solution of LDAA is going to fix the problem. Because what are we dereferencing here? Why do you think that is going to fix the problem? So that is kind of what your answers should look like. And this is also why, I think just commenting every single line to remember what is to mark what is in the register is just the way to do it. Okay, I think that's the best way to do it. Some people disagree. All right. So, okay, so given that we have the LD instruction between line 130 and line 131, everything is good. So now we look at this instruction here. So we go like, okay, this is the offset, to prep frame. Oh, we are missing an LD add instruction here, but there are actually more problems than that. Look at the prefix. This is frame underscore pref frame instead of is loop underscore pref frame. What are the differences? What is loop underscore pref frame representing? And what is frame underscore pref frame representing? To member. Yep, in the structure. Yes. What about is loop underscore pref frame? It's either a local variable or a parameter, but it's still the same thing. It is an offset from the base of the frame. So if the prefix is the name of a function, it is an offset from the base of a frame to something on the stack in the frame. If the prefix is the name of a structure, it is the offset to a member of a structure. So the second part can be the same. Okay, there's nothing in C or C++ that says you cannot use the name of a local variable also as the name of a member of a structure. There's no such rule. So that's why you have to pay attention to both the prefix and also the name after that and understand the difference between those two. So line 134 needs a correction, okay, because we need is loop underscore pref frame and not frame underscore pref frame. We also need an additional instruction between line 134 to and line 135, which is add AD, because otherwise you just have an offset from the base of the frame to either local variable or parameter preframe. That is not an address. Okay, you have to add the stack pointer, which is currently still pointing at the base of the frame, to the offset in order for A to become an actual address, so that line 135 would do its job correctly. So that's the correction here. All right, so that will take care of the right-hand side. The left-hand side, we have an offset, we have the address, then we have the store. All good here, not a problem. And now we have a nested loop, okay, the while loop. So when I see a while loop, I would move my little post-it to line 139 to remember this is where I have stopped. And then I look for the structure of the entire loop, which means I will look for the begin label, okay? I will look for the end label, which is down here. And then I will also look for the unconditional branch back to the beginning of the loop. That's what I would check structurally, okay? When all of these things check out, then I go back to where the post-it was and continue the analyze or analysis from line 140. So this tells you that you might want to bring some post-its with you as bookmarks. Yes. Hmm? Yes, you can. Absolutely. You can leave your post-its in if you want to, but I will have to take those out before I scan the exam. Um, Typically, you don't need to leave the post-its in when you submit it. But yes, you can bring post-its. You can bring all kinds of fancy colors, red for conditional statements, blue for loops and whatnot. I mean, knock yourself out. Because post-its, after all, is guess what? It's paper-based. Yep. Cool. All right. So now we look at the implementation, okay? So what this means is, okay, this is a conjunction, right? So that means, I need FPTR to be not null, and we also not need, this not equal to be true in order to stay in the loop, which also means if FPTR is null, I should get out of the loop, okay, without even asking the second question. So that's what I need to check first. So we have the offset, we have the address, we have the value, not in register C, but in register B. I, I force register B through the ALU and therefore setting the flags. And then I go like, if it is a 0, then we should exit the loop. Okay, so far so good. That is what it's supposed to do. Okay, and then we try to tackle the other side. And once again, this is not supposed to be, well, let me see. Nope, this is fine. Okay, so in this particular exam, I actually intentionally make it confusing because we have a local variable or parameter of the name p node, and we also have a member in the structure that is also called the p node. That was actually intentional. So now you have to ask, is this the right p node that we are referring to? You cannot know until you know what we are doing with it. Okay, so we are adding register A to register B. So now on line 151, you have to know what is in register B at that point. What is in register B by the time we get to line 151? What was the last time we put something into register B? Technically, it is line 148, but we know NBB does not change register B, so the last time we actually change register B would be line 147. So what did we accomplish on line 147? Register B becomes the value of FPTR. Okay, it is FPTR itself. Okay, so that means on line 151, we are adding the offset to member P node to the address or to the value of FPTR. What is FPTR again? It is a pointer to a struct frame. So that means it is an address of a struct frame. So that means, oh, okay, so after line 151, we end up with the address of member P node of the structure that is pointed to by FPTR in register B. That would be the conclusion of line 151. And then on line 152, we are going to that location and we are retrieving the value of member P node of the structure that is pointed to by PTR. That is what line 152 is accomplishing. So in this case, if you read the comment, it says start mandatory destination register documentation. It also explains what you need to do. So that means even though there are no bugs whatsoever from lines 145 to line 152, you have to tell me what is in the register after each line of the instructions. Even though there are no bugs to fix, the instruction says that's what you need to do. Is that okay? So you can probably tell that the the whole point of the final exam is you need to be able to track what is in the register and how does it relate to the C code, which is basically what we have been doing for the past, I don't know, 4 weeks ish, okay, with all the sample programs too. So what you can also do, okay, you can bring the sample programs with you with your own annotation. And if you have been following my advice and commenting every single sample program that we did in class, including the solution to struct2, you should have a fairly good idea of what the instructions are doing in the context of the C code. If you have not been doing that, you have about a week to kind of make up for that, okay? Which I think is doable, okay? It's going to be a little crunch, but it's doable. You can bring that with you, okay? All the sample programs, all the solution to all the homework assignment, all the labs too, okay? If you say, oh, I find this lab to be quite useful, print it out, bring it with you, okay? So you have all of those as resources, okay? But there's no resource will help people unless they already know what the resources mean, okay? So that is the most difficult part or the most challenging part is to understand the material, okay? All right, so we are now moving on to line 154, okay? So line 54 is corresponding to the Oh, okay. So this is okay. Let me just focus on these two lines here. What are these two lines doing? these two. There's a particular way to describe it as a stack operation. Okay, this is a huge hint. What are we doing with register C? And people who rely on pattern recognition should also be able to recognize these two and be able to answer that question. We are pushing register C on the stack. We are saving the value of register C on the stack. Okay, cool. Okay, so then after that, we go like, okay, now that we have saved the content of register C on the stack, let's go ahead and mess around with register C. So register C is now containing, after this instruction, how would you describe what register C has? Oh, by the way, there are certain kinds of comments that it's not going to get anyone any points. Okay, let me show you what I mean by that. So if the comment here, okay, is to say C equals to P node plus one, that would get no points whatsoever. I can read the assembly code too. Thank you very much. Okay, so that's not going to be helpful. So what is going to be helpful here? Well, first of all, there are a few questions. Okay, look at the next instruction here. Okay, this is trying to do. I will come back to the C code earlier. We're adding the stack pointer to register C. So that means register C is likely to be something on the frame. Okay, if it is something on the frame, this would be the wrong prefix because that's a prefix that you use when you're dealing with members of a structure. You're now dealing with something on the stack in the frame. So that means this needs to be changed to a is loop. Okay. And then the second thing is why do we have a one plus here? It's because of this decrement D. The stack pointer is no longer pointing to the base of the frame. It is now pointing to 1 byte below the base of the frame. So if I need to access anything on the frame, we need to get back to this. So in this case, register C is still ampersand p node minus the stack pointer. The reason why we have the 1 plus is the stack pointer is now decremented by 1. So by adding 1 to the offset here, we compensate for the stack pointer pointing to 1 byte below the base of the frame. So this statement would still be applicable, which means for the next statement, C ends up with the address of P node. Are we okay so far? So there are a few things that you have to take into consideration with this one. All right. So copying or writing down the answers to the final exam is kind of helpful, but the most useful part is, understanding what the thinking process that you have to go through. Okay, so if you can write down some notes to yourself, okay, this is a reminder, this is a checklist of things to watch out for or things to look out for. That might be helpful to some people. Okay, because after all, you are free to bring in any amount of paper and you can put anything on the paper too. I would say once you figure out what you a little checklist for you to go through, bring that checklist with you. Okay, so this way you're not relying on your memory. Go like, okay, what else do I need to check again? Oh, right. If it's a stack-based operation, we need to make sure the offset is to an item on the frame and not to a member of a structure. But if I'm adding the offset thing or the register to the address of a structure, then it should be an offset to a member and not an offset to an item on the frame. So if you once you figure out, okay, those are the things that you need to watch out for, make a checklist, bring it with you. Okay, make everything as structured as possible so that by the time you get to the final exam, you're not trying to figure out things at that time. You have a script to follow at that time. Okay, so I would do that. All right, so by the time we get to line 157, register C would be would be p node. Okay, it is the actual value of p node, which is what we need on one side. And oh, I lost track of which line I'm working with now. We are comparing A to C. Okay, okay, I got it. Okay, all right. So we're comparing A to C, and A is getting its value from where? All the way from here. Okay, so now you have to remember, oh, what did we put into register A on line 152? That's all. Okay, so we already remember that on line 150, on line 152, register A is the value of member P node of the structure that FPTR is pointing to. So that means register A is the left-hand side of the not equal to comparison. And then over here, by the time we get to line 160, register C, oops, I take it back. By the time we get to 158, register C has the right-hand side of the not equal to. So at that time, we just do a comparison, okay? So this is the compare. So the compare is going to set a bunch of flags, okay? All five flags, would be affected by the compare instruction, of which we only need the Z flag, okay? Then you go like, wait, Tech, aren't we supposed to use a conditional branch right after? No, that is the usual pattern, but it doesn't have to be like that, okay? So that is the trick, okay? Do not do pattern recognition. Okay, so instead of using the Z flag right away, I go like, wait, I got two more things to do. So as a combination, what do these two lines do? It is once again a stack operation. We had a push before. What is this? It's a pop. Yep. Whatever register C had before we push is now back in register C. So you probably want to comment what is in register C at this point, because we already figure out what was in register C before the push. So now we restore register C. Then somebody might say, but you're adding one to register D on line 161. Doesn't that kind of mess up all the flag registers? The answer is no, it does not. Okay? Increment and decrement are specifically designed not to change anything in the flags register. Okay? So that means whatever the flag register has because of the compare instruction continue to be there consistently by the time we get to the JZI. So we are basically saying, hey, if they are the same, we should probably get to the end of the loop because the logic of the loop is as long as they are different, stay in the loop, right? So what happens when they are the same? Get out of the loop, right? Get out of the loop. So that means, what should be the label here? Should we go back to the beginning, go for another iteration, which is the same thing as a continue? No, we should get out, right? So this should be end, okay? And you have to explain that, okay? Change the begin to end and explain that, when the two sides of the comparison equal, it is time to exit, not to go back to the beginning. So you need that explanation too. Alrighty. And then we get to this instruction, which is the same trick that we did before. Okay, this is calculating the differences between the offset to the previous frame and P node, and it is doing that to register A. So register A has uh, what does register A has? Oh, right. Okay. So this is fine. Okay. We are just putting this difference into register A, and then we add this difference to register B. So now you have to remember what is in register B. And this is why I still say that commenting every single line is going to be helpful because this was the last time that we modified register B. Register B contains the address of member P node of what PTR of FPTR is pointing to. So that register B continues to be this register B here before the add. So after the add, register B becomes the address of member previous frame of the structure that FPTR is pointing to, which is exactly the address of the right-hand side of the assignment. Okay, and then we have a dereference so that register B becomes the actual right-hand side, and then we do a store of register B to register C or whatever register is pointing to. That's after register C is popped from the stack. So that means in order to understand what line 167 is actually doing, you have to be tracking register C the whole time, which basically means, hey, if you comment all the previous lines, that makes your job actually easier by the time you get to line 167. Okay. So if you already have done the commenting with the sample code, the sample programs that I gave you guys after each class, this would be just like, oh, okay, instead of typing it, I'm just handwriting it. Okay, but it's the same kind of exercise. And at the very end, after this operation, we jump to the beginning of the loop. That's all good. This is the end of the loop. After we exit, this is what we evaluate. So by the time we get to here, we're looking at register C. It's like, what is in register C again? So register C is the same thing as when you exit from the loop. So that means anything that can potentially go to the end label, you have to look at that register C. So this particular register C has the address of FPTR, and then the other one, the other exit is over here. So this particular register C also has the address of FPTR. So that means consistently, we can go to this location and go like, okay, register C has the address of FPTR, which is close to what we need because we are not comparing the address of FPTR to 0. We're comparing the content or what is pointed to by FPTR to, no, I take it back. We're comparing FPTR itself, not the address of FPTR to 0. So that means right before line 172, we need an LDC in parentheses C, because otherwise you'll be comparing the address of FPTR to 0 and not FPTR itself to 0. Is that okay? So that's one correction here. So that will take care of the problem, okay? Because if that is 0, that means we just go to the else case of the ternary. We go to the or else because this is an or. So that means if the left-hand side turns out to be false, then we go to the second part and evaluate that. Otherwise, we go to or done because we just say that, oh, okay, the left-hand side of the or is true. We just go to the end, which is going to store something into result. Okay, so the or else is corresponding to the right-hand side of the logical or operation here, which is basically just calling its loop, blah blah blah, and so on. So we have to kind of see if this code is doing exactly that. We're supposed to push the address of f on the stack. This is the offset. This is the address. We push it on the stack. That's all good. Then we're supposed to push the value of member p next of the structure the p node is pointing to. So that means we have to get to p node first. This is actually correct because we have an extra decrement d at this point. So that means the stack pointer is pointing to 1 byte below the base of the frame, and therefore we need the 1 plus here to adjust for that. So this is still the offset of p node from the beginning of the structure. And then this one is still going to be the address of p node. And then we do one indirection so that we get to p node itself. We get to the offset from the beginning of a node to the member p next of the same node. We add that offset to the address of the structure. And that, so by the time we get to this instruction here, register B would be the address of member p next of the structure the p node is pointing to. We do one dereference to get to the value of the member, and then we push that on the stack. So this part is correct as well. Yes, I just said all of that stuff without writing anything down. So that means that when you're going through this, you should, I would recommend you to try to do this without listening to the lecture first. Okay, see if you can see how much you can figure out. Then you go back to the recorded lecture and then you go through that and see if you can fill in the blanks. All right. So with all the fixes, the program actually is supposed to work too. So you can also use River Spider to help you understand the code. All right. So now it jumps to so we push the parameters, right? So over here, okay, everything from here to here are pushing all the arguments on the stack, and then we do a JMPI. Am I forgetting something? How do you call a function? You push all the arguments, and then you push the return address. I forgot to push the return address. So that means between line 187 and line 188, line 188, you have to insert the lines of code to push the return address on the stack. Typically 3 lines of code to do that. So this is also a checklist item, okay? Because everything is based on the caller-callee agreement, which is a contract, which also means a checklist can do it, right? And we are running out of time. So we can stop here, okay, and continue this on Thursday. We do have class on Thursday. So I think that's what we're going to do is we're going to pause here and then we'll continue the test on Thursday. And between now and Thursday, what you can also do is to go through this by yourself, okay, without listening to the lecture or looking at the key and see how much of this you can figure out by yourself. And then if you have any questions as you go through this process, then you can bring those questions on Thursday. Then we can talk about those while we spend the rest of the class on Thursday to finish this. So that's what we're going to do. I will stay in the room if there are people who want to continue to talk about this, so we can do all that. And if you need to leave, you can go ahead. But I will stay here as long as there are people still staying here and want to ask questions. All right, no club meeting today. Okay. Yep, I know. Well, depends on what you guys are going to talk about. Some people may show up.